Good afternoon and welcome once again to our YouTube channel. Thanks for subscribing to our channel, and for those that are yet to subscribe, please kindly do so. Don't forget, every time you subscribe, you get easily notified of our new content as we upload them. Today I want to talk about a topic which is actually relating to the blood. We want to know the blood groups and the blood genotypes, how they relate, as we want to talk about transfusion and possible marriage matches. We want to talk about compatibility when it comes to marriage. So please, I will plead with you to follow us with what we want to talk about, as it is going to be very, very beneficial to you, for your siblings, family members, and everyone around you. You'll be able to give them the best information that they actually need. Alright, so let us pick it up. We want to talk about blood, as we have said, and we'll be picking up from the blood groups. So actually, we have 4 major blood groups, and those are the blood group A, the B, the AB, and the O. So we have 4 blood types that I have said, blood groups, or we can call them blood types. So we have the blood type A, we have the blood type B, we have the blood type AB, and we have the blood type O. So these are the major 4 blood types that we have. So it is important that you know your own blood type, and that will inform what you have to do in the nearest future. If there is a need for you to transfuse blood or to give blood, to donate blood, you will know what you are and what you can give. You will know what you can receive as well. So we'll quickly look into those, and that will help us to know the type of blood that can be transfused. So actually, there are basically 2 components of this blood type that we really need to know about if there is going to be the need for transfusion or blood donation. So what are these things? We want to look at what we refer to as the antigens and the antibodies. Again, the antigen and the antibodies. So what are the antigens? The antigens are actually found in the RBC, the red blood cell. That is where we have the antigens, while we have the antibodies in the plasma of the blood. So every blood has its own possibly antigen or antibodies, or in some cases we have both antigen and the antibodies in some blood types. So we'll quickly look at the chart that talks about these blood types, talk about their characteristic properties, and then how possible it can be to actually transfuse blood. So let us quickly look at their characteristics first. So we want to look at the characteristics. Let's put that here. We have the blood characteristics. Blood group characteristics or properties. Alright, so let us list the blood types here. Blood types. So we have the A, we have the B, we have the AB, and we have the O. So here I will quickly list that we have the antigen. Like I said, the antigen is found in the RBC, in the red blood cell, and we have the antibody that is found in the plasma. So like I said, the antigen is found in the red blood cell, and it is the major component that determines the blood group, while the antibody is found in the plasma, and it is the natural body immune or defense mechanism. It is responsible for defending our body against invaders, against germs, against diseases that might want to harm the body. So let us look at it. The blood type A. The blood type A has the antigen A. The blood type A has antigen A. And for the antibody, it has what? The anti-B antibody. That is the type of antibody that we have on the blood type A. The blood type A has antigen A, and then the antibody is anti-B antibody. Let us see what we have for the next one, which is blood type B. It has the antigen B. Blood type B has antigen B, and the antibody is the anti-A antibody. It has anti-A antibody. And for the blood type AB, the blood type AB has both antigens, antigen it has, yes, antigen A, not anti-A. It has antigen A and antigen B. On the other hand, it has no antibody. The AB has antigen A and antigen B, but it has no antibody. While for this blood type O, the blood type O has no antigen at all, and on the other hand, it has what? The anti-A and the anti-B antibodies. So if you look at it very well now, you will get to understand that we said that the blood type A has the antigen A and the anti-B antibody. That means it cannot receive. The anti here means against B. So A is always going to be against B. That is what the anti-B antibody here is talking about. So A has antigen A, then anti-B antibody, while B has antigen B and anti-A antibody. That means the B cannot receive blood from A. Then AB has what? Both antigens. It has antigen A and antigen B, but it does not have any form of antibody. While the blood type O has no antigen at all, while it has the anti-A and the anti-B antibody. So if we know this, that will inform our decision when there is a need for transfusion of blood. Let us quickly see. I'll put that here. How possible is it to transfuse blood? If you have this at the back of your mind, then you know that any blood type that has the antigen A and anti-B, that means the blood type can collect blood from A, but from this one here, the anti-B, it is telling you that it cannot receive blood from B. So that is what it is. So let us quickly use that. Since we have that information, let us quickly use that to see how possible it is to actually donate or receive blood. So I'll quickly put that here. Right? Let me use this as our recipients. And here we'll be having our donors. Alright, so I want to have recipient A, B, B, and O. Those are the recipients, and here I want to have A, B, and O. Like we can see what we have on the board. So I will be using asterisks and the tick sign to actually identify what is going to happen here. So look at this now. We already said this here, the A, B, and O here, they are the recipients, while we have the A, B, and O as the donors. In this scenario, A wants to donate to A. So if we come back to this chart that we had here, we said that A has antigen A, but it is against B. Now look at this. A has the same antigen with this recipient, this is A, but it is against B because it has anti-B antibody. Since this A does not have anti-B, because what we have here is A, it's not B. So it is not definitely going to be against this one. So we have what? A being able to donate to A, so we say this one is possible. Now, that is for this. Now on the other hand here we have A, which has antigen A, ready to donate. And we have B that has, this is B here, and it has anti-A antibody. That means it does not want to receive any antigen from A. So look up, that means A cannot donate to B because this B is against A. That is the meaning of anti-A. So that means this is actually not possible. Now, let us go to the next one. We said A has antigen A. Here we have AB. AB has what? If you see here, it has antigen A and antigen B. That means since it has antigen A, that is the same as the antigen for blood group A. What we are saying is AB has the same antigen with A. Blood group A has antigen A. Blood group AB also has antigen A. That that means there's a possibility of AB getting blood from what? From A. On the other hand here, if you look at the antibody, AB does not have any antibody. Since AB does not have any antibody, that means it is possible for it to what? Receive blood from any group, because there is nothing that it will go against. So that means A can actually donate to AB. And the last one here, can A donate to O? Let us see. A has antigen A and anti-B antibody. O does not have any antigen, then it has anti-A and anti-B. Since O blood group has anti-A antibody, that means it is not going to be able to collect blood from A. So that means this is actually not possible. I believe we are getting what we're talking about here. So let us go to the next one, which is the B, blood group B. A donor who is having a blood group B, who is anticipating to donate blood, how possible is it to donate to all of these groups that we have just talked about? So can B donate to A if B here has antigen B and it has anti-A? Since it has anti-A, that means it is against A. So it will not be possible for A to donate to, for B to donate to A. So this is not going to be possible. Are we following? Now, we have B with antigen B. Will it be possible for B to donate to B? Yes, because B has antigen B, which this recipient also has, and then the antibody that B, this recipient, the antibody that this B recipient has is anti-A, not B. So that means it is possible for this to actually happen. And then the next one, B can also donate to AB, because AB has antigen B, like the blood group B. The blood group B has antigen B, so also the blood group AB. And since AB does not have any antibody, it is possible for the blood group B to donate blood to AB. So this is also possible. And can it be possible for B to donate to O? That is not going to be possible, because B has antigen B and then anti-A antibody. B again has B antigen, then anti-A antibody. But if you look at O, blood group O here has anti-A and anti-B. This anti-B here that this blood group O has is the reason why it will be possible for it to collect blood from a blood that has antigen B. So this also will not be possible. And then if you look at the AB has antigen A, antigen B. So it does not have any antibody. Therefore, the recipient which is going to be A, in this case here, from AB donating to A, AB is the donor, while the A is the recipient in this scenario. We have A to have anti-B antibody. That means this AB has, look up, it has antigen B. This antigen B that AB has is the reason why B, this AB now will not be able to donate to A, because A is against B. That is the meaning of this anti-B that we have here. So AB having antigen B will not be possible to donate to the A blood type, because it is having the anti-B. So this is actually not going to be possible. And something similar to that is what happens in the second case, where we see AB donating to B. That is also not possible, because AB has antigen AB, and that is what it is the antigen, the anti-B that A has. On the other hand, B now has anti-A antibody. The anti-A antibody is against the antigen A that B is what not wanting. So that is why this will not also be possible. But will it be possible for AB to donate to AB? Yes, that is actually very, very possible. AB can donate to AB, because it has both of them have the same antigen, and they do not have any antibody. So this is actually possible. And then the last one there, we have AB donating to O. That is absolutely not possible, because AB has antigen AB but no antibody, while O has no antigen but it has the anti-A and the anti-B antibody. So O is against A and against B, and those are the things that AB has. O is against A and against B, and those are the characteristics or the attributes of the blood group AB. It has the antigen A and the antigen B, and so we say it is not possible. And on the last run here, we have O donating its blood. The O is donating its blood to the A. That is very, very possible because O here does not have any antigen. Since O does not have any antigen, there is nothing for A to go against. So that means this is actually possible. And then for B, O does not have any antigen like we have said, so it can also donate its blood to B. So this is also possible. And for AB, O again does not have any antigen, so it can donate its blood to AB, who does not even have any antibody. So that is also possible. And O can also donate to O. So if you look at this now, we can understand the reason why you probably must have heard people calling the blood group O a universal donor. If you look at it now, if you look at the chart having the O, you can see that it's possible for O as a donor to donate to all the groups. O can donate to A, can donate to B, can donate to AB, and can also donate to O. So that is why we refer to this as the universal donor. Universal donor. And if you look here, we always see our AB on the recipient angle here. AB can receive from A, it can receive from B, it can receive from AB, and it can also receive from O. That is why AB is always referred to as the universal recipient. So with this, I believe you understand what we actually talk about when we are talking about blood group and blood transfusion. So with this knowledge, we also need to understand what genotype is. Genotype is actually the genetic makeup of the human being or of every animal, so of every organism, every living thing. Every living thing has its own very, very unique genotype. So the genotype is the genetic makeup of all the genes in the body. Now, in humans, we have basically 6 types of genotypes. So let us quickly look at this. We have basically 6 types of genotypes in the human race. So these are the major genotypes. Genotypes in human. Genotypes in humans. Now, we have them listed thus. We have the AA, we have the AC, we have the AS, we have the SC, we have the SS. 1, 2, 3, 4, 5. Alright. Then the last one we have the CC. Alright. So basically these are the 6 blood genotypes that we have. This one here, the AA, happens to be the commonest. Let me not say the commonest, but the very normal genotype. Because this one here is seen as the sickle cell. This is the sickle cell anemia. And this one here is a carrier, a sickle cell carrier. This one here is termed what? Hemoglobin C carrier or disease. Or disorder. Let me use disorder so you don't get it wrong. So this is oftentimes seen as a normal genotype. Now, if we look at this 4, or this 6 rather, it is very important for every intending couple to know their blood work. Know your blood group, know your genotype. This information will go a long way in determining what your home will turn out to be. If you want to have peace of mind in your marriage, it starts from here. You actually need to know your blood group and your genotype. Now, let us quickly see the possibility that we can have when we have the genotypes crossing or matching one another. If AA happens to marry any other blood type, that is the reason why it's actually called the normal blood group. If AA gets to marry any other blood type, then there is a very possibility of a successful home. Why? Because the worst case scenario of AA is, even if AA marries SS, is that the offsprings will be AS. That the offsprings will be what? Carriers of the disease. And none of them will be what? Actually the sickle cell patients. They will only be carriers of the sickle cell trait. So that is the worst case scenario. So if AA marries AA, for example, we have AA marrying AA. Here we can have this, where AA will always be the offspring that will be what? Will be gotten. So that is the possibility. When we have AA marrying AA, we always have all of the offspring, the possibility of the offspring to be AA. Unlike when we have AA marrying AS. Yes, AA can also marry AS. In fact, that is the most possible advisable means where AA marries AS. So we can have all of the offsprings being AS. They are only carriers of the trait. So the reason why we actually call AA the normal trait is because it saves other gene or other types of genotype. In a scenario where, because all of this, when we have the SC, the SS, the CC, AS as well, they always have some health conditions. They oftentimes have health conditions that varies from light cold to severe fever and the rest of those. But in the case of the AA, the commonest ailment that they have is malaria. That is the commonest of their ailment or their sickness. So when AA marries any other type of genotype, it is possible for the blood to actually get helped, or let me say, it will be possible for the fellow to be able to transit from that. But in the case where we have SS marrying any other cell apart from AA, this is the possibility. When we have SS marrying any other trait, if SS marries SC, for example, we'll be having this possibility. SS, SC, SS, and SC. Now, this is going to be very, very painful, because in the scenario where a sickle cell patient, somebody who has a sickle cell anemia, and somebody who is having this type of trait, that is the sickle cell and the hemoglobin C, whose type of ailment ranges from, we have the likes of jaundice. Yes, let me just list a few of the health conditions for this. When we talk about the CC or the SC, this particularly the ones that have what the C genotype, the hemoglobin C disorder, we have jaundice, we have anemia. Yes, those are part of the health conditions, jaundice, anemia, and the rest of those, because we don't want to actually waste too much of our time. So if the CC or the SC is marrying the SS, then we have this SC, 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 SC. All of this is going to give a very, very painful outcome. So the only possibility that we have, which is going to be the most suitable, is when AA marries any other one. If AA marries CC, for example, what we'll be having is going to be AC. Here, we'll also be having AC. Here also will be AC. AC. That is the possibility that we have. Even if it is the AA marrying the AS, AA marrying AS, the possibility we'll be having is going to be AA, AS, AA, and AS. Now I am told that is the possibility when AA marries AS. The possibility is that we have two of the offsprings being AA genotype and two of the offsprings having AS genotype. That is the possibility. So it is going to be 50-50. Now, the painful aspect is for those who probably might be thinking that if this is the condition, okay, if I have AA as the firstborn and then I can stop. This is not in the order that it is always going to come. We are only explaining to you that this is the possibility of the offspring. Any one of these four can come to be the firstborn or the secondborn. And it can be so very lucky or luckily or unluckily that a particular trait here, a particular genotype here is what comes and it reoccurs after it must have happened previously. So we need to be very, very careful at this particular point. So if there is a need for you to go into a relationship and you know that you are a sickle cell carrier or the hemoglobin C carrier, you need to be very, very watchful. It is very, very important that you know where you are footing. You know that the only blood group that the genotype that you need to entangle yourself with or to go into a relationship with, if it is going to be a long-term relationship, is the AA genotype. Please don't forget to subscribe to our channel because we know that a lot of us are yet to do so, and from what we have seen, we know that we'll be getting more interesting topics and contents sent across to our screen. Please like this page, like our content, share our content as well, and don't forget, we'll get across to you with more beautiful topics. Thank you very much and God bless.